YouTube. Let's see if this is working. I think this is working. Let me see if I can get the chat up. How are you? It is the week before the AS Maths exam. So, and, oh, hang on. Let me, this is working. I think this is working. Get rid of myself, talking at myself. Thanks, Christopher. Okay, so basically I've got half an hour. I'm all yours. We can do some AS Maths, some A2 Maths, some pure, some stats, some mechanics, whatever you would like. We can have a look at how are you feeling about the exams? What preparation have you done? Do you feel ready? I bet you don't. No one ever feels ready for a maths exam. If I was going to be taking a maths exam next week, I wouldn't feel ready. No. The web class is on in the web class. So if you go into Taylor Tutors, that's 6 till 8, the web class. And that is, the link is in the web classes course in your Taylor Tutor subscription. This is just literally drop in anybody that's got any questions, anybody that needs any extra bit of help, or anyone that wants to sort of talk about, just try and minimize this, talk about, doesn't it? Okay, I was wondering why no one was signing up. Let's have a look. Give me 1 sec and I will. Maybe I can put the link back in. What happens when you click on the link? Okay, let's get this link again. Sorry about this, won't be one. Yeah, you're right, nobody has joined it, which is a bit weird. Okay, so there's the link. I'm gonna put the link into the course and then we'll do some maths. Okay. So meanwhile, I want to know from you, how many papers have you done? How many practice papers have you done more than once in test conditions? So you've done a paper, have you done any again in test conditions, just to see how you get on the second time or the third time or the fourth time? How many actual papers have you done like that? Right. 9th of the 5th, that is today. Link, putting the link in. Okay. Save. All right, try now. Okay, try now. See if it works. Right, so I've put the link in again, so have a look and see if it's working. If it's not working, then tell me, because I thought if it's not working, I'll have to investigate more. I thought it was fine, that link. Okay, so how much stats is there in the... Yay, excellent, cool. What I'll do is I'll chat on here for half an hour and help people out, and then I'll go and approve everybody after that. So don't worry about the approval thing, because I'll do that when we finish here. Okay, what was the question? How much stats? Do I teach statistics? Yeah, absolutely. And how much stats is on the Ultimate Guide? All of it. All of the stats is in the Ultimate Guide. All of the mechanics, all the stats, and all of the pure. As for right now, we've got half an hour, and I can help you with whatever you're feeling the most worried about. But I want to know the answer to this question. So, how many papers have you done more than once? So 4 or 5, 2. Anybody else? Anybody done an entire paper and then later done that exact paper again? Because this is the way that you get the most progress in maths. It seems really, really silly. And I know that there's this pressure. I've had it myself, and I've done maths exams quite recently. I did an Open University course, and you've got all of these past papers. And what you actually have access to is almost too much, because, well, I think it is too much, because you feel like in order to be successful in the exam, you have to do all the past papers, all of the mixed exercises, like all of the crash maths papers, all of the IYGB, whatever they're called, papers, like all of the old spec. You literally cannot do every maths question that's ever been written, and every maths paper, even for the last sort of 4 or 5 years. It'd be ridiculous. It's impossible. So then what happens is you can start to feel really stressed because you're not doing all the questions. But actually, that doesn't help. Just going question, 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 question. It doesn't help. It's redoing the papers that really helps. So if there's nothing else you do differently between now and the exams, just try that. Take one paper or 1 year. So paper 1, paper 2 for AS, paper 1, paper 2, paper 3 for A level, and do the paper and then work on it. Go through the mark scheme, ask people for help, blah, 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 and then do that exact paper again. And you will find that you get much higher, but not as much higher as you would think. You don't get it all right. Things have fallen back out. And then it's a case of putting them back in and then trying that process again. And then that is the quickest way. Honestly, that is the quickest way to, right, large data set. I would say do one thing with the large, well, two things with the large, three things. One is to make a list of what's in it and what their units are. So just like, this is not going to be loads of work. It's 3 marks maximum, and a lot of 2 of those marks you can probably just blag without even looking at it. So first of all, go to the large data set for your board and just write down what it is that is in it, so that when you see words like local authority and butter and margarine and I can't even remember what the other, cloud cover and wind speed and that sort of thing, at least have an idea of the data that your large data set covers, okay? Just a really minimal idea, and that will allow you to recognize what's going on and maybe blag one of the questions a little bit. The second thing that you need to know is any outliers, because really it's very, if you think what they're testing, okay, they're supposed to be testing you on this enormous knowledge of this enormous spreadsheet of data. They cannot possibly be expecting you to know individual bits of data. So what can they ask you? They could ask you to identify an outlier. That is a really, really popular question. How do you add another course onto TT? Well, from within the course, you can add something on. So like for the ultimate guide, you can add on the revision kit, or for the revision kit, you can add on the ultimate guide. I think if you go in the My Courses page, there's a button there. Or if that is not what you want to do and it's any more complicated than that, then hop, what time is it now? At 6 o'clock, Trav will be on the chat on the Tailored Tutors website. So I would say that's probably quickest. Just at 6 o'clock, go to the Tailored Tutors website, hop on the chat, and Trav will help you out with your account. Okay, Amy, don't worry about large data set. Literally download it, have a look what is in it. You don't need to know about the actual numbers, just like it's about this data, this data, this data, and this data is all integers, this data is all in loads of decimal places, this type of data is numbers from 0 to 10, that kind of thing. Just a really vague idea of what is in the data set, and then make a note of any outliers for each type. So the most common questions I've seen across all of the boards, and I think this is going to be a theme, I think maybe now and again they'll come up with a new type of question, but if you're just going to do minimal input revision wise for maximum potential marks, then I would just do this. Find out what the data is, what type of numbers, and the outliers. So the questions that I've seen, they have a scatter graph, and it's like scattering around, and then there's like one major outlier. And they say, what is the outlier? So you're supposed to know it's London, or you're supposed to know it's margarine, or you're supposed to know it's oil, or you're supposed to know it's whatever the other one is, I can't remember. So outliers, common question. The other one, which I've seen quite a lot, is where they say, so-and-so thinks that this data does this. And like, why might they be wrong? And then it's an extract from the large data set, but it's to the nearest integer or to the nearest 3 significant figures or something like that. So because you know that that particular measurement is like actually measured to 10 decimal places, when you see it to the nearest 100 or the nearest 10 or the nearest 5 or whatever, you know it's been rounded. And then you can say the data's been rounded. In the large data set, there is much more accuracy, which would mean that the numbers would give you that. You know, to be honest, I would just write that down. I would blag it anyway. So if it's one of those questions, so like these numbers look like they do this, why might it be wrong? Just write down that they've been rounded. And in the large data set, there was more accuracy. And so this calculation might not be completely accurate. It's 3 marks, okay? 3 marks, of which one of them you'll be able to blag. I'm sure you'll just be able to like use common sense, make it up. But there are things which are worth way more. So if you think the amount of to guarantee those 2 marks or to make it likely you're going to get those extra 2 marks, the amount of work you would have to do to get that large data set in your head is huge. Whereas something like integration is going to come up 100%. Trig identities will come up. There will be a trig equation and probably a trig proof. So put that time into trig and integration and differentiation, not into large data set, not worth it. The third thing, the thing I just thought of that I would say about large data set, when you're doing a past paper, when you get to the large data set question, have a go. And then when you're marking it, don't go and look at the mark scheme, because you will gain nothing from that and you've wasted an opportunity. Instead, go to the actual large data. This is going to be really hard for you to do. You'll want to just look at the answer. But go to the large data set and try to answer that question using the actual data. I know you can't do that in the exam, but it will teach you a little bit. It will take you 2 seconds. It will teach you a little bit more about the large data set, and it will make it more likely that you can blag an answer or know the answer when it comes to the real thing. Okay, you don't get why. Yeah, ours is not to wonder why. Ours is to blag the exams and jump through the hoops and get as many marks as possible for the least possible work. That is our job. Who cares why it's in there? It's not worth hardly any marks at all. And if you do 10 minutes work on it doing what I just suggested, leave it. That'll do. Okay, last one you did was about sweets. Yeah, I do find those really difficult, but I think that what you definitely don't want to do is to start stressing about it, really. I mean, okay, how about this? Just think of the last maths that you did in test conditions. Okay, so it doesn't matter whether it's pure mechanics or stats, just think back. It could have been in your house or in the library or in a test. The last time you did some maths in test conditions, did any of you make a mistake? Just a little, like, duh, I can't believe I did that type mistake somewhere. Yes, Harry, the class is at 6 o'clock, 6 till 8. Yep. So any sort of mistake, and by mistake, I just mean like one that you look at and you think, I knew that. I don't know why I did that. Like a 2 changes to a 3, or a minus sign, or disappears, or a minus sign changes to a plus, or you copy the question wrong, or you don't put units on, or it says leave your answer in this form and you didn't, anything like that. Okay. So how many marks-ish do you think you lose by doing those sorts of mistakes? Ish. Like 5 on a paper, maybe more, maybe pushing 10 marks on a paper, on a whole paper, like 2 hours. If you did 2 hours maths, how many marks are you likely to drop? I think probably most students drop 5 to 10 across the paper, maybe more, but ish, yeah, ish 5 to 10 is probably average. Now 10 is a whole grade, 5 is half a grade. Now, how many of you have practiced finding mistakes in test conditions? Probably not many of you. You're just kind of hoping that in the exam they won't happen, or you're hoping in the exam you'll find them, even though you've never actually actively practiced trying to find them. And you know that every single time you do maths, you do make mistakes. So, but yeah, there's some sort of like, well, there's nothing I can do about that. Of course, there's something you can do about it. Of course there is. And that effort, any minutes that you put in the next week or 2, any minutes at all that you put into doing maths in test conditions and then not looking at the mark scheme until you've been through that maths and practiced improving your accuracy, practiced trying to find the mistakes. What techniques are there? You know, do you just read it through? Do you do the whole paper again? You haven't got time for that. You need some actual strategies, like subbing numbers into both sides and see if they work, or sub the answer to an equation back in and see if it is the solution to the equation, or learn how to use your calculator to solve equations, all that stuff. Any minutes that you put into that is going to get you way more marks next week, week after that than large data set. Okay, honestly, that is where your focus needs to be. You can add a grade onto your exam in 1 week simply by focusing on practicing finding mistakes and correcting them and learning that skill, which is something that nobody practices. Oh, Spider, I wish that too. I really want to do the physics. I'm not a physics teacher, but I've done the physics exams. I've learnt the course, but at the moment, maths is like all of my time and then some, so I just can't. But I am thinking of doing, possibly doing a sort of physics. I could do like a physics drop-in help, or like, I don't know. Something, I might do something. Right. Is there anything that you would like to do? How is the mark scheme making? How was the mark scheme making for Edexcel? Oh, we do that we start on the day of the exam. I haven't seen the paper. The people who, well, there is some crossover in the teams, but the people who write the paper and develop the paper, that is a sort of different team from the people who do the mark schemes and run the marking process. So there's an overlap, but I'm not in that team. I'm in the marking team. I don't want to be in that team because then I would know what was in it and then I couldn't teach. I couldn't teach you, could I? Because how would I do that if I genuinely knew what was in it? Just having my turmeric shot, which is really, really strong and it's really good for you. But it's like, not my favorite thing. Okay, any maths you want to do? Any advice you want about revision? Or any particular topics you'd like me to go through? Or like literally, we've got a quarter of an hour, I'm all yours. We could do any topic you like from the A-level. The exam marker is a tutor. Yeah, that's fine because you've done the exam by then. By the time we give the mark scheme to the examiners, you've all done the exam, so that doesn't matter. Okay, all of integration and the range for difficult functions. Okay, integration then. Second year integration, I assume, not first year integration. First year integration is easy, isn't it? Timings, Darshan, will improve if you do the process I was saying of redoing papers, because it trains you to start to speed up. And because you're doing that in conjunction with practicing finding mistakes, then you don't do that thing that we often do in maths, where the faster you go, the more mistakes you make. So you have to focus on those two different competing skills of speeding up and also becoming more accurate. So that is a combination of redoing the same paper over and over and over, but also not allowing yourself to look at the mark scheme until you've literally gone through every question and practiced accuracy finding. And that process, that combining those two together, that will help you to speed up and get faster. One more answer. Somebody said, when are you doing predictions? Right, bear in mind, I have not seen the paper. I have not asked anybody about the paper. I have no clue what is in the paper, other than that I've taught the Edexcel for 15 years, more probably. So I do know the style of question and I know the style of paper, and I obviously marked it last year and I marked the internationals all through the year. So I've seen quite a few of the new spec papers, and so I'm going to do some predictions on Sunday at 6 p.m, but they are not based on anything other than my experience of what these exams are like, which is obviously more than your experience, but that'll be Sunday at 6 o'clock, okay? Integration. I think that was the only questions that you were asking. Okay. Right, how to do this. So has anyone heard of backwards chain rule? Has anyone learnt backwards chain rule? It'll be an hour on Sunday. Try and get this out of the way so that I can share my screen. Nope, good, yes, okay. Now, backwards chain rule is usually how integration is taught, and I really don't like it, okay? So I'm gonna show you how I teach integration, but I want you to bear in mind that the way that I teach integration is that I start teaching integration at the beginning of October. Okay, this is really important. So any first years watching, bear this in mind now. This time next year, you won't be able to integrate. None of the second years can integrate. Second years find integration very, very difficult, okay? And that is, in my opinion, because it's taught way too late and there isn't time for your brain to assimilate all the methods and actually slowly build up those techniques in the way that they should be built up. The integration chapter is always quite late in the book. Lots and lots of colleges and schools just work through the book. So by the time you get to integration, it's this huge chapter. You end up swimming around with all these different techniques. You don't know what is going on, and then suddenly it's exam revision and you don't know how to integrate, and it's hard. So I teach integration from October, and I build it up slowly, slowly, slowly every single week from October. Now, what I'm going to do is run you through the process that I use to teach it, but you have to bear in mind that this is not going to be like me teaching you something like binomial expansion, or like finding the range of certain functions, or like how to use the continuity correction when you do the normal approximation, or how to find the max and minimum values in R cos x plus a. I could teach you that in 3 seconds and then you'd be able to do it. But integration takes ages, so you do need to practice, okay? But I will show you how I think about it and the process. Am I plugged in? Yes, I am. The process that I use to explain integration to students. Right. Let me just check that you can actually see my screen. Can you let me know when you can see an iPad screen rather than, can you see this? Let me do it again. Integration, is that working? Good, Amy, good. What school are you at? I like your school. If it's okay to ask, is it all right to know what school you're at? I don't know. Right, integration. So you go into an exam and you see this integral, okay? There are only 2 options for this integral. One of them is that you can guess what the answer is. Okay, and the other one is that you need to fiddle around with it and then guess what the answer is. They are the only 2 possibilities. You can't see my screen. Good. Okay, excellent. Thank you for letting me know. Hang on. Let me see if I can stop share. Share. iPad share. Let's try this. If not, I've got a whiteboard. I'll grab the whiteboard and do it on that. It's not doing it, is it? You're right. It's just black, yeah? Okay. Okay, in that case, I've got a whiteboard, but I'm just, first of all, just going to talk to you about it and you can write down, okay? So there are 2 types of integral. There are integrals that you can guess what the answer is immediately. And there are integrals which you have to do something in order to be able to guess what the answer is immediately, all right? So can you see me and hear me? That's what's important at the moment. So when you look at this integral, you need to know whether or not you can just write down the answer, or whether or not you need to do some fiddling around in order to be able to just write down the answer. Now, fiddling around, what does that mean? At its most basic level, it involves, and you can write these down if you want, expanding out brackets, so like something squared, might have to expand out brackets, simplifying a fraction, so for example, like x plus 1 all over x, you could write it as 1 plus 1 over x. So that's brackets, expanding brackets, simplifying fractions. Next, most complicated, a trig identity. There are standard ones that I'll talk you through, but a trig identity might be needed. Next one, you might have to use partial fractions and in order to pull something apart, and then it's fine. And then 2 more, which is integration by substitution and integration by parts. So these methods here, you've got expanding out brackets and I'm doing it in my head now. Expanding out brackets, basic fiddling around with fractions, just tidying them up, not like algebraic division or anything like that. Then you've got trig identities, using trig identities and simplifying trig expressions. And then you've got partial fractions. And I guess we should put algebraic division in there as well, like partial fractions and algebraic division, not just simple mucking around with fractions, like a bit more sophisticated mucking around with fractions. And then you've got substitution and parts, okay? Now those things, what those things do is not integrate. Those things do not integrate a function. They are not methods of integration. They are methods to take an integral that you can't do and turn it into one that you can do, okay? So totally separate things. Integrals you can do, integrals that need you to use a method in order to turn them into integrals that you can do. 6 of those methods. Right. The hard bit, therefore, the most important bit, is how do you do the ones that you can do? How do you recognize them? And then once you've done your method, once you've done the algebraic division or the partial fractions or the fiddling around with the fractions or expanding brackets or a bit of trig identity or integration by parts or integration by substitution, then you get this integral that you've got to actually integrate. And the question is, what do they look like and how do you know that you've got one? Now, there are only 10. I'm thinking what the other ones are that I would say I would add on. 1, 2, 3, 4, 5, 6, 7. Okay, so there are going to be 10 things that you actually integrate, and then 7 things that I'm going to tell you how to integrate because they're just like so common. So there's going to be 10, then there's going to be 7 extra ones, okay? And then there is all of those little methods that turn them into this, which we can discuss separately if you want to. But that lot, integration by parts, integration by substitution, partial fractions, algebraic division, using trig identities, blah, 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 that is not integration. That's turning it into something which needs integration. Right. The 10. These are the, I promise you will not be able to find something, an integral, which is not one of these 10, or I can't turn into one of these 10 using one of those methods. Promise. They are sine of something. I'm going to go relatively slow so that you can write them. Sine of thing, cos of thing, sec squared of thing. Sine, cos, sec squared. Cosec squared of thing, thing being the angle. Cosec cot, cosec thing, cot thing. Sec thing, tan thing. That's 6 so far. Sine, cos, sec squared, cosec squared, sec tan, cosec cot. E to the thing, a to the thing, 1 over thing, and thing to the power of something. Okay, 10. 10 things. Now, how do you integrate those? Because those are the only 10 things. They are the only 10 things in the whole time you've been integrating. You probably don't believe me at the moment. You're probably flicking through your notes to find a counterexample. You won't be able to. They are the only 10 things that we actually integrate. Everything else is about getting it into one of those things, those 10 things. So if you know how to do those 10 things, if you know how to integrate those 10 things, then when you're looking at the integral, all you need to think is it one of those 10? Yes, brilliant, done. Is it not one of those 10? Okay, in which case, which of those techniques do I need to fiddle it into one of those 10? Okay. So, how do we integrate them? Sine of thing has come from cos of thing. That's the answer. Okay. Can I say the 10? The 10, Megan? Cos thing, sine thing, sec squared thing, cosec squared thing, sec thing, tan thing, cosec thing, cot thing, e to the thing, a to the thing being ax plus b, 1 over thing, and thing to the power of something. Nothing else. And the way that you actually integrate them, the way that you know what the answer is that you know which function got differentiated to become that. And that is the answer, because when we're integrating, we're undifferentiating. We're thinking what got differentiated. So if it's the integral of sine, then you know it's come from cos. If it's the integral of cos, it's come from sine. If it's the integral of sec squared, it's come from tan. If it's the integral of cosec squared, it's come from cot. If it's the integral of sec tan, it's come from sec. If it's the integral of cosec cot, it's come from cot. No. If it's the integral of cosec squared, it's come from cot. If it's the integral of cosec cot, it's come from cosec. If it's the integral of e to the, it's come from e to the. If it's the integral of a to the, it's come from a to the. If it's the integral of a thing to the power of n, it's come from that same thing to the power of n plus 1. And finally, if it's 1 over thing, then it's come from ln thing. And when I say come from, I mean that the function that got differentiated is the thing, you know those 10, you know what thing differentiates to make that. That is it. Okay, there are 7 more which I will tell you about, not because they're any different, but just because they're kind of like standard ones that I would say everybody needs to know. So, Spider, where did you get lost? Did you get so initially we talked about the ones you can do and the ones you need to fiddle around with. We talked about the fact there's 6 fiddling around methods that you need to know in order to turn them into this pile. And then in this pile, yes, Moses, I do have tricks, yeah. In this pile, there's 10 things. Did you get lost on what the 10 are, or did you get lost on how you would know what the integral was if you got one of those 10? Which of those bits would you like me to go over? Because I'll go over those 10 one more time, like what the answer would be. So if you're integrating sine, if you've got the integral of sine of a thing, then the answer is cos of that thing. I know there might be a number at the front, don't worry about that for now. If it's the integral of sine of something, the answer is cos of that thing, because when you differentiate cos, you get sine. So when you're looking at that integral of one of these 10 functions, and you only integrate 10 things in total, ever, honestly, when you're looking at the integral of one of those 10, what you think to yourself is, which function differentiates to give that? So the integral of sine is cos. The integral of cos is sine, because sine differentiates to cos. The integral of sec squared is tan, because tan differentiates to sec squared. The integral of cosec squared is cot, because cot differentiates to give cosec squared. Don't worry about minus signs for now, we'll come back to that. The integral of sec tan is sec, because sec differentiates to sec tan. So I'm doing differentiation in my head, not integration. The integral of cosec cot is cosec, because cosec differentiates to give cosec cot. The integral of e to the is e to the. The integral of a to the is a to the. The integral of 1 over is ln. The integral of to the power of n is to the power of n plus 1, 1 higher. Okay? So that bit there that I just said, I can't use the board, because when I click share, here it is, look, here is the board, and it is plugged in, and it is plugged in there as well. Let me check. Yep, it is plugged in there as well. And then when I click on share, iPad, this is what happens. Let's see if it's going to do it. No, it's black. Black. Okay, I've got, wait a sec. We've only got like 10 minutes. This bit probably is easier if I write it. So I'll get this one. Okay, but I need to go and get a pen, a board pen. So just give me 1 sec and I'll get a board pen. Okay, see if any of these work. Let's see, how am I also, like, am I gonna, wait, that's not gonna work, because I'm right-handed. I think we need to do this. Okay, can you see this? Okay, I'll make it so I can see the chat. Right, so this, I mean, maybe I need to do it a bit smaller because if I need to get 10 in, this is the only things you integrate. Let me see if I've got a better pen. What have we got? Sine cos sec squared, sec tan cosec squared, cosec cot, and x to the n, and e to the x, and a to the x. Okay, now what we discussed is, I don't know if that's been there years, I don't think I'll ever get that off. What we discussed is what the answer to these is. So you do have to know how to integrate these. You do have to know that. There's no getting around that. You have to know how to integrate these. But everything else turns into one of these. And then the process that you do is as follows. So say we get, let's have this one, sec squared. And I can change this x to anything like, so long as it's just not squaring or anything complicated, like any timesing and adding. So like 3x plus pi. And I could put any number I want at the start. I don't know, 6, like that. Okay. Now what you do when you look at your integral, which will be one of these 10, because we only integrate these 10, when you look at it, you think, what must have been differentiated? So in this case, it is tan. And all you do is you write down the thing that must have been differentiated. And you don't worry about anything else. You just write down the thing that must have been differentiated. So here it would be a to the something, e to the something, x to the n plus 1. This one, it would be cosec. This would be ln, that would be cos, that would be sine. So you just write down the function that must have been differentiated, okay? Now you differentiate the thing you've written down, because that is what you think the answer is. So you differentiate this. You can do it at the side, you can do it even in your head, depending on how good you are with the chain rule. It's all about the chain rule. So what happens if we differentiate this? We differentiate tan, we'd get sec squared. Good. But then we have to multiply by the derivative of the inside, which is 3. So this would be, I'll just jot it down at the side. This is what it would be, 3 sec squared, 3x add pi. Now I'm almost exactly right, but I don't want a 3 here, I want a 6. So all I need to do to change that into what I actually want, which is a 6, is stick a 2 here. Done. That's the process. That is how all integration works. Now, can anyone come up with an integral? They're hard to type in, I know, but see if you can find somewhere in your book or something, an integral which you think doesn't follow that pattern. I'm just going to try and wipe some of this off. Or like, try and find something that you think contradicts what I've just said here. Okay, any integral at all. Like literally, I'm not. And then what I'll do last is the 7 extras that I think you should just memorize how to do because they're easy. But those 7 are this as well. Has anyone got an integral that they think, no, it isn't that simple? Because look at this one. This is more complicated than that. You won't be able to. And then, yeah, I'll show you the extra 7. Arctan, no. No. You might get this. And you might get asked to differentiate it. That's the same as saying y is arctan x. And they might say, what is dy by dx? You could get that. But that's not differentiating. I know it looks like it's differentiating arctan, but it isn't. It's using implicit differentiation here. So you would differentiate both sides with respect to y. And then use the fact that 1 plus tan squared y is sec squared y. and tan squared y is x squared, so that's 1 plus x squared. So that goes there. And then you turn them both upside down. Now, I guess they could then say to you, part A, do that. And then they could say part B, hence integrate 1 over 1 plus x squared dx. And then if they did that, then you would say, right, okay, what do we do when we integrate? We try to write down what got differentiated. Well, I know what gets differentiated to make 1 over 1 plus x squared. I literally just did it. What I differentiated was arctan x. So this is arctan x. So no, they would not ask you to integrate the to get the inverse ones. Oh, yay, we've got an actual integral here. Okay, but they could ask you to differentiate. Okay, so this one is 2 sine x minus cos x plus x. Okay, so do these functions fit into the 10 things that I integrate? Yes. I integrate sine, cos, sec squared, cosec squared, cosec cot, sec tan, e to the, a to the, x to the n, that's that one, and 1 over x. So this is 3 of my 7, which means I don't have to do anything. I can just write down what I think the answer is. So I think that this bit, what got differentiated was that. And I think this bit, what got differentiated was that. And I think this bit, what got differentiated was that. Now I'm going to differentiate them and see if it works. When I I need a 2 there. That's okay. I'll just put the 2 there. When I differentiate cos, I get minus sine. Almost right, not quite. Now it works. When I differentiate sine, I get cos, and that needs to be a minus. That works. When I differentiate x squared, I get 2x. So I don't want that 2, so I'm just going to whack that there, and then that's done. Anybody got a harder one? And then I'll show you the 7, and then I need to go sort out my lesson for my students. But you're all welcome to join me in my lesson if you want to join Tailored Tutors. Only for 1 month. There's only 1 month left. It will be the best 50 quid you ever spent. For 1 month, you get access to me 24/7, and you get 2 hours a week of lessons. And yeah, and it means I can go a little bit slower, doesn't it? Because we've got the lessons, and also like all of the tutorials there, all the past papers, all of the questions. And you can ask questions on any one. Tan to the 4. Okay, this is going to be the last one. Okay, tan to the 4. Okay. Okay, that is not one of the 10. Okay, that's not one of the 10. It isn't sine cos sec squared, cosec cot sec tan, e to the a to the 1 over x to the n. Maybe a substitution. Don't forget we've got 6 things that we can do. One of them is substitution and one of them is parts, but don't just jump down there because there's other stuff. There's like fiddling around with fractions, there's expanding brackets, there's trig identities, and there's partial fractions and algebraic division. Now, I agree that's not going to be helpful and that's not going to be, well, no. So I'm going to go with trig identities, okay? Predictions are on Sunday at 6 o'clock on YouTube. I'm going to write this as tan squared x times tan squared x. All right so far? Then I'm going to change tan squared to sec squared. And then I'm going to expand that out. And then I'm going to change that tan squared to 1 minus sec squared. No, sorry, sec squared minus 1. Now, that's my fiddling about. I've done my fiddling about using trig identities, haven't used anything else. And now I can tell you that everything is from our 10, okay? Everything is. This one has come from tan. That one, just the number -1, has come from -x. This one is something cubed. This one is tan x cubed. And you see why. I know that's reflecting off the screen, but this one is tan x cubed because I'm always looking at these integrals and thinking, what would I have differentiated to get that? And I know that sec squared is the derivative of tan, and I know how the chain rule works. So I know that if I differentiate this, the 3 would come down, change to a 2, and then I'd multiply by the derivative of tan, which is sec squared. So the only difference between that and that is I don't want that 3, which I can deal with very easily. Done. Done. Tan differentiates to sec squared, minus x differentiates to 1, done. Okay, so what did I do there? I looked at tan to the 4 and I said that is not one of the 10 things that I differentiate. It's not sine, cos, tan, sec, cosec, cot, e, ln, and a to that. That's it. That's the only 10. So I went down my list and I thought, oh, I'm going to try fiddling around with some trig identities because I know tan squared and sec squared link up. So I did some trig identities and then I was able to just write down what got differentiated. Yep, that is it. But I say that's it. This takes practice, okay? You can't just. But I promise you, there are no integrals that don't fit into that pattern. And yeah, sometimes you use double. That's a trig identity. Double angle is a trig identity. So yeah, sometimes you use that. Okay, I need to go. I will be here. Anyone who's Taylor Tutor student, I will be in the class in 15 minutes. So I'll go do the registration now. So if you've registered, I'll send you the link. And anybody else who isn't, become Taylor Tutors just for 1 month. Let me help you with your maths. Yeah, Guardian, exactly. When do you choose when to use substitution and when to use trig identities? More or less, I would use identities unless it said use a substitution. I know sometimes it doesn't say use a substitution and a substitution is best, but that's rare. It's much more, when I'm doing examining, it's much more common to see students launching into a substitution or parts when actually you can just write down the answer. And the best students just do one line and they go, boom, that's the answer. And then the students who are trying to sort of use an algorithm for integration, they will do loads of complicated parts and substitutions because parts and substitution are like a method. Bit like quotient rule, product rule. It feels nice to have something that you can do that you know the steps for, but it's not the best way to integrate at all. Yes, that's fine. I'm going to do the registrations now. So I'm going to go and do the registrations, and we're going to have our maths class. And yeah, anybody watching this later, I'm going to be on here Sunday 6 o'clock talking about like what I think is going to be, well, some things I know are going to be in it, like integration, but like what's your best strategy? What should you focus on in that last few days or last few weeks? That's Sunday at 6 o'clock. And I'm always going to be on here until I start examining. I'm going to be on here Thursdays at 5. See you later.